All right, guys, so what we're starting now is going to be the bulk of the free responses. Okay? So when you go to do the free responses in the AP test, it's going to have integration. Going to have integration. One thing that you guys all saw on those formulas was sigma, right? What does sigma represent? Add them all up. Basically, add them all up. This entire section, the rest of the semester is basically, we're going to take areas of a whole bunch of really small things and add them all up to find the area under the curve. We're going to use a limit process as the limit approaches infinity, because then if it approaches infinity, it's going to be so small, it's going to be the actual area under the curve. Right? We're going to start by doing the limit process on how to find it. Actually, we're going to start with anti-differentiation, where you just kind of go with your gut and what it is. And then we're going to kind of formalize it, and then we're going to do the limit process with sigma and the limit as it approaches infinity. And then, even by the end of today, you will be using this symbol right here. That symbol will always have d and then some variable right there. 9 times out of 10 it'll be x, sometimes it can, or it's going to be t. Like dt, the t for time. More often than not, you'll see it like this, or you'll see it like this. Time, and then just x. That's integration. The integration is going to mean like displacement, or area under the curve, or the total displacement of the function, or something along those lines. But really, all this is a derivative backwards. We're going to call this anti-differentiation. Yes? Anti-differentiation means it's going to be a generic answer where there's an infinite amount of answers. If I put something up here like, I don't know, 3x squared. If I wanted to go backwards, say that this was f prime. If I wanted f of x, what would that be? What would f of x be? X cubed. Would everybody agree this is a derivative of x cubed? How did you kind of come up with that? Reverse the derivative process, or more importantly, you reverse which rule? It is because you would take what? If you had x to the n, if you took the derivative, it would be nx to the n minus 1, yes? So if we go backwards with this, I could do x to the n. If I take the integral of this, it's going to be x to the n plus 1 over the n plus 1. Would that work here? 2 plus 1 is 3, because now where are my erasers? So this is what we're going to start with, just like we started with on derivatives. If we had 3, if we're going to integrate 3x squared dx, that's the whole symbol, well, everything. With the derivative, were you allowed to pull the constant out? Yes? Yeah. Same here, pull your constant out. 3 to the integral x squared dx. Now, this becomes 3 times x to the 2 plus 1 over the 2 plus 1 by the reverse power rule. And then this just gives me 3x cubed over 3. My 3's cancel, and I have x cubed. Yeah? So this doesn't seem terribly bad. Pretty straightforward, right? Yes? Okay. Yes, we're about to talk about it. But I am going to solve this differential equation for you. Y prime equals 2. That's my derivative. Let's also go to differential equation. I want the antiderivative of this. This one's pretty straightforward. What's the antiderivative of this? Y is going to equal what? Say it louder. 2x. Everybody agree that 2 is just the 2x is the derivative of 2x. What we need to do, because constant, what's the derivative of a constant? So I don't know if there's a constant that we got rid of over here, right? We always have to put plus c. That's the anti-differentiation part. You have to put the plus c. If not, you're wrong. I'll say that again. You have to put the plus c or you're wrong. You will lose all your points. Let's see if this may not show up. This may not show up on the. Y'all see that graph there? Right here, it says the integral of 3x squared minus 1 dx. So that's the graph. This is only part of the solution graph. What does each one of these represent? The c, the plus c, is moving up and down. So there's an infinite amount going up, there's an infinite amount going down. So if I ask you to graph this with plus c, you can't because there's an infinite amount of graphs. But if I ask you to graph just like 3 or 4 of them, you can. But they all are the correct solution. A little mind-boggling, right? All right. Wow, that looks horrible on the camera. Okay. So far, so good? Yeah? Pretty easy? Here, I want you to try this. I want you to find the general solution. When I say general solution is what I had up here. Y equals 2x plus c. The general solution is I have to have the constant of integration. This is called the constant of integration. So this is a general solution. Like if you remember in pre-cal, when we said general solution for trig, we always had to have some sort of formula, right? That was generic for a whole bunch of them. Infinite answers. Same here. All right. I want y'all to find me the general solution to y prime equals 4x cubed. Find me the general solution. Give you what, 3 minutes? Just a few minutes. On the AP test, I put it everywhere you possibly can. All right, guys, listen up. So, question to me was on the plus c, when to put it in. For me, in class, as long as you have it at the very end, you're fine. On the AP test, play it safe. As soon as you integrate, put it everywhere. As soon as you integrate, put the plus c and keep it all the way through. All right, just play it safe. All right, Chelsea, what'd you get? Y equals x to the 4th power plus c. All right, Chandler, is that what you got? Cool. All right, let's talk some notation. You can do the integral. Well, let me just write it. Kind of looks crazy, right? This part right here. Yeah, I'm just using capital F. This is the integrand. So the integrand is the functional part, the function part of it. This right here, the variable of integration. Totally think I misspelled integration, but it's okay. This part right here is your antiderivative. This right here is your constant of integration. So if I ask you what your integrand is, you should be able to tell me what it is. If I ask you what your variable of integration is, you should be able to tell me what that is. If I tell you, hey, what's the antiderivative, you should know what that is. Sometimes we're going to find very specific constants of integration, very specific ones instead of the generic plus C. Any questions about just the makeup of this with the vocabulary on it? Sean, you got a copy down? All right. So I'm going to go ahead. Y'all ready? We're going to do some integration. But before I do this, I'm going to refresh you. All right? I don't think you are. I don't think you're ready. All right, here we go. What is the derivative of sine? What is the derivative of cosine? Negative sine. What is the derivative of negative sine?
Negative cosine.
What is the derivative of negative cosine?
Sine.
So if I go this way, this is d dx, right? Or dd theta. That's an easy way to remember sine, cosine, tangent, or sine and cosine as the derivatives. If you go the opposite way, because the antiderivative is the opposite, it's your integral. So what is the integral of cosine? What is the integral of sine? What is the integral of negative cosine? And the integral of negative sine is? So these are your integrals. So that actually gives you your derivatives and your integrals. You have to remember the direction that you're going. Y'all got that copied down? Yeah? All right. Jonathan, you good? Was you not good?
I'm fine.
Okay.
Yeah.
I'm going to do a couple examples here. I don't have a lot of room here. I haven't shown you this last one yet, so I'll explain when we get there. So I'm going to do these integrations, kind of show you an easy little strategy. Last semester, you should have been told exponent rules, exponent rules, exponent rules. Memorize them. Know how to write the exponent rules back and forth. Were y'all told that? Because exponent rules make calculus so much easier. Because I'm going to rewrite this as the integral x to the negative 3 dx. Now when I integrate this, I now have x to the negative 3 plus 1 over negative 3 plus 1 plus c, right? So this becomes what? X to the negative 2 over negative 2 plus c, which should give me a negative 1/2 x squared plus c. Y'all agree with that? The negative for this exponent means it's in the denominator, and then it's squared. So a lot of times with this integration, if you can, write it as with exponents, it'll make your life easier. What's the exponent of the square root of x? 1/2. So I can rewrite this as the integral of x to the 1/2 dx, which then becomes x to the 1/2 plus 1 over 1/2 plus 1 plus c. X to the 3/2 over 3/2 plus c, which gives me 2x 3/2, just leave it in exponent form, over 3 plus c. Do not bother changing this back, just leave it just like that. Leave it as the exponent. Does this seem terribly bad? No? Everybody caught up? Few people writing so. I want to take a drink. Now y'all are probably wondering, how is this one of the hardest classes Mr. Buzzard took? College. Integral calculus. Because this is like baby steps. We're not going to do anything nearly as difficult as you'll have to take when you take integral calculus in college. But you will know the basics of integration from AP Calculus. What we're doing is pretty straightforward. Right here, the only thing I'm going to do first is what? You should always do what? Huh? Take out the 2. Pull your constants out. Always pull your constants out. Take your 2 right there. I'm going to integrate sine x dx. What is the integral of sine x? What is it?
Integral.
What is the integral or the antiderivative of sine x? Negative cosine. So now I have negative 2 cosine x plus c, and I'm done. What's the first step to do right here? Huh? We can do that. I'm not going to. I'm going to pull the 3 out. I'm going to leave it as the integral of 1 over x dx. Guys, the integral of 1 over x is the ln of absolute value of x. So you can only do this rule as long as x does not equal, as long as your n doesn't equal 1. When it's 1 like this, negative 1, it's always going to be ln of the absolute value of x plus c. That's just another integral rule. The integral of 1 over x dx is ln to the absolute value of x. That would be a good time that y'all start building integral tables, like you could put to your calculator. Well, what's really nice is in your calculator, if you find integral, the integral symbol is, I don't have my calculator out, that one button where you get to like the second derivative and the nth derivative. That button right there. The one next to the book. And if you do just the basic integral, so back out of. Oh yeah, oh you leave blank. This one? Yeah, that one. Where'd you find that one at? Oh, guys, go to the bottom left. It doesn't have, does that one have the boxes on it? No, yeah, bottom left is your indefinite integral or the antiderivative. So guys, the calculator will do all these for you. However, on the AP test, most of the free responses, you're going to have to do an integral by hand, so we've got to practice these by hand. So what I'm going to do is I'm going to erase these, and I'm going to put some up for y'all to practice. I want you to practice them by hand, and then you can check them in the calculator, okay? Now, what did the calculator not put in there? Plus C. So you yourself have to remember the plus C. All right, guys, I'm gonna give you some problems to practice. Let's do the integral of the 5th root of x squared dx. Let's do the integral of 5 secant squared theta d theta. And I'll give you the integral of secant squared here in a second. And the integral of 1 over 2x dx. So he jumped right to x to the 7/5 over 7/5. I'm okay with that. I'm a big boy. I know what he did. And then he's got 5x to the 7/5 over 7 plus c. Y'all get that?
Yes.
All right. Trey. If you're going to rewrite your integral, you better have your variable of integration. They will take points on. You need to have that. If you're going to write it, you need to have that. Don't be lazy. So he pulled his constant out, and then the integral of, another thing. As soon as you take that integration, so you got me straight tripping.
Oh, you're straight tripping.
Secant squared is the tangent. Get rid of the integral. As soon as you do the integral, get rid of it. It's just like with the math symbol. As soon as you're done adding, you get rid of the addition sign, right? Get rid of it. And then he just rewrote it with the plus c. I don't know why he just put the plus c there, but okay, whatever.
What? That's what I heard.
Could have just wrote the plus c there and be done with it. Alright, right here, pull out your constant 1/2, the integral of 1 over x dx, which is, okay, don't be lazy, guys. Put this 1/2 in there. You aren't going to lose points on the test. Put that stuff in there. And then this is okay. ln of the absolute value of x over 2 plus c. That's perfectly fine. But put that 1/2 in there. Don't be lazy. Right? Don't be lazy. Other questions, concerns, comments? Yeah, you can stop right here. You don't have to do this. You can stop right here. In fact, I'd prefer you guys to stop right here with this instead of just doing this. Either one are wrong, you'll get full credit for both of them. How much time we got? I'm not going to start the next thing. We have a total of 3 days for this section, but it's only going to take 2. Good. That's plus 1 day. All right, guys, that's it. Good job today.